Right now, something is moving through our solar system that has Harvard scientists publishing papers with the word spacecraft in them. Not speculation, not maybe. Actual peer-reviewed research suggesting we might be looking at technology from another civilization. And the evidence is getting harder to ignore. 3 months ago, a 20-kilometer object entered our solar system traveling at speeds that broke every record we have for interstellar visitors. Scientists named it 3I/ATLAS. At first, they thought it was just another comet passing through. But then the data started coming back from our most advanced telescopes. The James Webb, the Hubble, the Very Large Telescope in Chile. And what they found doesn't match anything natural we've ever seen. Dr. Avi Loeb, the Harvard astrophysicist who spent his career studying the universe's most extreme objects, looked at this data and said something that shocked the scientific world. He couldn't rule out that we're looking at artificial technology, and now 20 other astronomers have signed papers saying the same thing. Here's what you need to understand about interstellar objects. In all of human history, we've only confirmed 3 of them passing through our solar system. 3. Out of billions of years of cosmic traffic, we've caught exactly 3 visitors from other star systems. The first one, Oumuamua in 2017, was already weird enough that it sparked years of debate. It accelerated in ways that didn't match any comet behavior we understood. Some scientists suggested it could be a light sail, an ultra-thin reflective sheet pushed by starlight. Others said it was just outgassing in unusual patterns. The debate never really ended. Then came Borisov in 2019. More normal, more comet-like, but still strange in its composition. Scientists were starting to think maybe interstellar objects were just naturally weird because they formed in different stellar environments with different chemistry. But 3I/ATLAS isn't just weird. It's breaking the rules in ways that make both explanations, natural or artificial, seem almost impossible. And that's what's got Harvard's attention. Because when something doesn't fit either category we understand, that's usually when we're about to learn something completely new about the universe. The question everyone's asking now is simple but profound. Are we looking at the universe's most unusual natural object? Or are we looking at the first confirmed evidence that we're not alone? Let me show you why this object has scientists questioning everything they thought they knew about space rocks. When 3I/ATLAS was first spotted by the ATLAS telescope survey in Chile, on July 1st, astronomers immediately started calculating its trajectory. Standard procedure. You track the object, plot its path, calculate its speed and orbital mechanics. This is stuff we do hundreds of times a year with asteroids and comets. But the numbers that came back didn't make sense. First, the speed. 3I/ATLAS is moving at 58 kilometers per second with an orbital eccentricity of 6.1. That's the highest eccentricity ever recorded for any object in our solar system. To put that in perspective, most comets have eccentricities between 0.5 and 1. Anything above 1 means it came from interstellar space. But 6.1? That's not just unusual. That's record-breaking by a massive margin. Then came the trajectory analysis. And this is where things get really strange. The object's path places it within 5 degrees of Earth's orbital plane. In the vastness of space, where objects can approach from literally any angle in 3-dimensional space, the chance of naturally aligning this closely with our planetary orbits is about 0.2%. Already unlikely. But it gets worse. As astronomers tracked its path forward, they realized 3I/ATLAS would make close approaches to multiple planets. It would pass 0.65 astronomical units from Venus. That's about 97 million kilometers, which in space terms is remarkably close. Then 0.19 units from Mars, then 0.36 units from Jupiter. The combined probability of all 3 close approaches happening by random chance? About 0.005%. That's 5 in 100,000. Dr. Loeb put it bluntly in his first analysis paper. These numbers don't look like randomness. They look like someone plotted a course. Now, to be clear, low probability doesn't mean impossible. Unlikely things happen all the time in a universe this big. Flip a coin 1,000,000 times, and eventually you'll get 20 heads in a row. But here's the thing that makes this different. When you combine this trajectory with everything else about 3I/ATLAS, The improbable starts looking deliberate. And that's what's keeping scientists up at night. The James Webb Space Telescope gave us our first detailed look at 3I/ATLAS's composition in August, and the data it sent back created more questions than answers. Normal comets have a fairly predictable chemical makeup: water ice, carbon dioxide, carbon monoxide, dust particles, maybe some organic compounds. The ratios vary depending on where the comet formed, but they stay within certain bounds we understand. 3I/ATLAS has a carbon dioxide to water ratio of 8 to 1. That's 18 times higher than what we'd expect for an object at its distance from the Sun. This represents what's called a 4.5 sigma deviation from normal cometary behavior. In statistics, a 3 sigma deviation is considered highly significant. It means there's only a 0.3% chance this is random variation. A 4.5 sigma deviation? We're talking about odds so small they barely register. This is the kind of deviation that makes scientists question whether they're even looking at the same type of object. But the chemistry gets stranger. The Very Large Telescope in Chile detected something in September that shouldn't be possible: atomic nickel emissions without corresponding iron signatures. In every natural comet we've studied, nickel and iron appear together because they form together in stellar environments. They're part of the same nucleosynthesis processes that create heavy elements in dying stars. Seeing nickel without iron is like finding sodium without chlorine in table salt. The chemistry doesn't work unless something has separated them. And there's no natural process we know of that would do that in a comet. Then there's the color change. As 3I/ATLAS moved closer to the Sun, observers noticed it shifting from reddish to green, accompanied by unusually strong cyanide production. The carbon dioxide dominated its atmosphere at 87% of the gas mass, with carbon monoxide at 9% and water at only 4%. This composition is fundamentally different from every solar system comet we've ever studied. It's not just unusual, it's alien in the most literal sense of the word. This is chemistry from a different stellar environment, formed under conditions we can barely imagine. And here's what really bothers scientists. If this thing formed naturally in another star system, its chemistry should still follow the same basic rules of physics and stellar evolution we see everywhere else. Elements form in predictable ways. Chemical bonds follow universal laws, but 3I/ATLAS seems to be following different rules, unless it didn't form naturally at all. On July 21st, the Hubble Space Telescope captured images of 3I/ATLAS that changed everything. Every comet and asteroid we've ever studied shines by reflected sunlight. They're chunks of rock and ice that glow because the sun's light bounces off their surface. It's basic optics. The brightness we see is directly proportional to how much sunlight hits the object and how reflective its surface is. But when Harvard's team analyzed the Hubble images, they found something that contradicted this basic principle. 3I/ATLAS appears to be generating its own light. Dr. Loeb and his colleague Eric Quito ran detailed analysis on the brightness profile. What they found was that the nucleus itself was producing most of the observed illumination. This wasn't reflected sunlight. Something inside this object was actively creating light. Now, there are a few natural explanations for objects glowing in space. Radioactive decay from supernova remnants, for example. When a massive star explodes, it creates heavy radioactive elements that can glow for millions of years as they decay. But Harvard's team calculated the probability of finding enough radioactive material in interstellar space to power the kind of illumination they were seeing. The numbers don't work. These materials are incredibly rare in the space between stars. You'd need to collect material from multiple supernova remnants, concentrate it somehow, and shape it into a 20-kilometer object. The odds are astronomically small, which left them with a hypothesis that sounds like science fiction, but appears in actual peer-reviewed papers. I'm going to read you the exact quote from Dr. Loeb's research paper published in August. Alternatively, 3I/ATLAS could be a spacecraft powered by nuclear energy, and the dust emitted from its frontal surface might be from dirt that accumulated on its surface during its interstellar travel. This cannot be ruled out, but requires better evidence to be viable. A nuclear-powered spacecraft, in a paper published by Harvard University. reviewed by other scientists who didn't reject it as crazy speculation. Think about what this means. This isn't some guy on the internet making wild claims. This is one of the world's leading astrophysicists looking at data from humanity's most advanced telescopes and saying he can't rule out artificial technology. But Loeb didn't stop there, because the implications of this hypothesis go way beyond just aliens exist. Dr. Loeb published a second paper in September with two collaborators, Adam Hibbard and Adam Kroll. This one explored what they called the dark forest implications of 3I/ATLAS. The dark forest hypothesis comes from a science fiction novel by Liu Cixin, but the science behind Loeb's analysis is completely serious. The idea is simple but disturbing. If the universe is full of intelligent civilizations, why haven't we heard from any of them? One possible answer: they're all staying quiet on purpose, because any civilization that broadcasts its existence might attract the attention of hostile neighbors. In this scenario, the galaxy is like a dark forest. Every civilization is a hunter, moving silently, staying hidden, because making noise could get you killed. If 3I/ATLAS is artificial technology, its arrival could represent exactly what the dark forest hypothesis warns against: first contact, but not the friendly kind. Harvard's analysis noted something that makes this even more concerning. 3I/ATLAS will be hidden behind the sun at perihelion, its closest approach to our star. This positioning creates optimal conditions for what they call a reverse solar Oberth maneuver, a technique for using solar gravity to break and remain bound to the solar system. In other words, if something intelligent is controlling this object, it could use this hidden position behind the sun to change course and stick around permanently, all while being completely invisible to Earth-based telescopes during the most critical part of its maneuver. The timing is also notable. 3I/ATLAS approaches its closest point to the sun on October 29th, right during solar minimum, when observation conditions are optimal for hiding things you don't want detected. Now, before this sounds too much like a thriller movie, I need to be clear. Dr. Loeb isn't saying this is definitely what's happening. He's saying the data we have doesn't rule it out. And that's actually more disturbing, because it means we genuinely don't know. Here's where the story gets really interesting, because we might actually be able to find out what 3I/ATLAS really is. Harvard has proposed using NASA's Juno spacecraft, currently orbiting Jupiter, to intercept 3I/ATLAS. The calculations show it's actually possible. With a delta V adjustment of 2.6755 kilometers per second, applied on September 9th, 2025, Juno could reach 3I/ATLAS at its closest approach to Jupiter on March 16th, 2026. This isn't science fiction. This is an actual mission proposal with real orbital mechanics and feasible fuel requirements. Juno has all the instruments needed to answer the big questions: near-infrared spectrometers to analyze the composition, magnetometers to detect any artificial magnetic fields, imaging systems good enough to see surface details from kilometers away. If 3I/ATLAS is natural, Juno would show us chemistry and geology unlike anything in our solar system. That alone would be groundbreaking. But if it's artificial, we'd be looking at the first confirmed evidence of extraterrestrial technology: images of constructed surfaces, materials that don't occur naturally, maybe even functioning systems. Think about what this means. We're potentially 6 months away from one of the biggest discoveries in human history. And it's not theoretical. The spacecraft exists. The trajectory is calculated. The only question is whether NASA decides to extend Juno's mission beyond its planned September 2025 termination date. But here's the catch. The window is closing fast. 3I/ATLAS will pass behind the sun during its closest approach, hidden from Earth-based observation precisely when it would be most active. If we don't send Juno, we might miss our only chance to examine this object up close. So where does this leave us? We have an interstellar object with a trajectory that defies probability, chemistry that doesn't match any natural formation process we understand, self-illumination that suggests active power generation, and timing that could enable covert operations in our solar system. 20 astronomers have signed papers saying they can't rule out artificial technology. That's not conspiracy theorists on the internet. That's mainstream scientists putting their reputations on the line. Whether 3I/ATLAS turns out to be the universe's strangest natural object or humanity's first contact with alien technology, it's already changed how we think about what's possible. Harvard has developed new protocols for evaluating anomalous interstellar objects. The Loeb scale now exists to classify potentially artificial characteristics in future discoveries. But maybe the most important thing is this: we might actually get answers. The Juno mission could happen. The October observations during its solar approach could reveal new data. And every day that 3I/ATLAS moves through our solar system, we're gathering more evidence. This isn't just another space mystery. This is happening right now. And what we discover could rewrite everything we thought we knew about our place in the universe. Subscribe if you want to know what happens when we finally find out the truth.